Hi, we have the AP Physics 1 past paper 2022. We are discussing free response question section. In this section, question number 5 carry the 7 points. The question is the spring of unknown spring constant K naught is attached to the ceiling. A lightweight hanger is attached to the lower end of the spring. A motion detector is placed on a floor facing upward directly under the hanger as shown in a figure like this. Now, the bottom of the hanger is 1 meter above the motion detector. A 0.5 kg object is placed on a hanger and allowed to come to the rest at equilibrium position. The spring then stretched downward distance d naught from the equilibrium released at the t0 motion detector. Record the height of the bottom of the hanger as a function of time. The output of motion detector is shown in a graph for the following page. As you can see, this is the equilibrium position 60. So it's mean when we add the hanger weight object to the spring, it come to the equilibrium position 60. So there is 0.40 extension of the by adding the mass, there is the extension of 0.04. Okay, we'll now calculate what is asking. Use the information and take the graph, calculate the spring constant. Hanger bottom is 1 meter above the detector before adding the mass. Now attach the mass, equilibrium height is 0.6. That's the information we get from the graph. Now stretch is 1 minus 0.6 is equal to 0.4. Now we get the spring stretch. F is equal to K naught X. F is equal to mg. Both left side right side should be equal to. So K naught is equal to mg by x. We have the mass, we have the value of g, we have the value of x. So answer of spring constant is 12.25 Newton per meter. Now, question is at 0.75 the object spring system has the total kinetic energy K naught and total potential energy U naught. At 1.13 second the object spring mass system has the total kinetic energy K naught and total potential energy U naught. Explain how the feature of graph indicate that total kinetic energy of the system is same at these two times. Now, first of all, we have to find the position time graph. The slope of represent the velocity v is equal to delta x over delta t. From here, we get the delta x, and from here we get the delta t. So that's the velocity. If we calculate the time 0.75 second at this instant and 1.13 second almost at this instant, so that's the same situation you can see. So slope is almost identical, steep is almost identical. So at 0.75, 0.13 curve have the same slope size as the two movements. One is going up, one is going coming down. So its slope is same. That means the velocity is same. Same height means same speeds, so same kinetic energy because mass is same, 1 by 2 is same. If velocity is same at 2 point, so kinetic energy is same at these two instants. Now explain briefly what total potential energy of the system same at these two times. If we totally discuss total potential energy of the object spring my earth system, the gravitational potential energy is there, elastic potential energy is there, but both these position energies depend upon the position. At these two instants, objects is at same height from the earth, from the ground. The spring is stretched by the same amount, mean x is same. Okay, so the both gravitational and spring potential energy are the same because both have the same value at these instants, so their gravitational potential energy should be same. We can this also from the law of conservation of energy. If kinetic total energy is equal to the sum of kinetic plus potential, if kinetic is same, so in these scenarios, so potential is also same in these scenarios. So we can answer in respect to the law of conservation of energy reference also. Okay. Now, the experiment is repeated with the spring constant 4k naught and the same length original spring. 0.5 kg object is hung to the new spring and allowed come to the rest to the new equilibrium position. Determine the new equilibrium position above the motion detector. Okay, we have the F is equal to 4k naught x. Now, because the k is replaced, now F is equal to mg x. We new stretch mg over 4x naught. we can separate mg over k naught. This is representing the old x, so that is 0.4. So we come to the new stretch, that is 0.1. If the k is 4 times bigger, so hence stretch is 4 times lesser. From the equation we get this info. So new equilibrium position is total unstretched position is 1 meter with stretch zero point 0.1. So we get the equilibrium position is 0.9 meter. Okay. Now object gain pulled down with the same distance from the d naught from the equilibrium position released. Graph on the following graph, draw the curve representing the motion of object after the release. Label the vertical axis with the appropriate numerical scale. Grid for the scratch practice book also provided. Okay. Now we have to come to know that there is a, new scale. Now time period is equal to the uh, 2 pi m by 4k. If we separate 2 pi square root m by k naught, this is the older time period. In previous case, time period, as we come to the previous graph, that is equal to the one of the oscillation. So that is complete into 1.25. So we get this information from the old graph. Now from this we place the value. Now the new time period is 0.625. So you can see I have drawn the new wave that is at 0.625. It is complete the twice as many oscillation in the same time. So you can see in the same scenario or same time 1.25 second it completed the two oscillation. So that's the change by increasing the spring constant is there. Okay, that's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly share and subscribe with your friends. Share with your friends. Okay, take care.